Space is enormous. So enormous that even the word enormous begins to lose its meaning when you try to imagine it for too long. Tonight, we're going to travel farther than humanity has ever traveled before. Farther than any spacecraft. Farther than the distant planets, beyond the stars of the Milky Way, and past the billions of galaxies scattered across the darkness. We're going to the edge of the observable universe. And somewhere beyond that edge lies one of the greatest mysteries in existence. What is outside the universe? At first, the question sounds simple. Almost childish. But the deeper you think about it, the stranger it becomes. Because every single thing we have ever known exists inside the universe. Every planet. Every star. Every black hole. Every living creature. Even time itself. So if the universe contains everything, how can anything exist outside it? To begin understanding this mystery, we first need to understand something important. The universe we can see is not necessarily the entire universe. It is only the observable part. Imagine standing alone in the middle of a vast dark ocean at night. Your flashlight can only illuminate a small circle around you. Beyond that circle, the ocean continues into darkness, hidden from view. That is similar to our place in the cosmos. There may be infinitely more universe beyond what we can observe. But because light travels at a limited speed, we can only see a certain distance into space. Scientists call this region the observable universe. Right now, its radius is about 46.5 billion light-years in every direction. And yet the universe itself is only around 13.8 billion years old. At first, that makes no sense. How can we see something farther away than the age of the universe should allow? The answer lies in expansion. The universe itself is growing. Not like an explosion flying outward into empty space, but more like space itself stretching over time. Imagine tiny dots drawn on the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. The dots are not moving across the surface. The surface itself is expanding. This is similar to our universe. Galaxies are being carried apart as space stretches between them. And while light travels toward us, the universe keeps expanding the entire time. This means the galaxies that emitted the light we see today are now much farther away than they were when that light first began its journey. In other words, when we look deep into space, we are also looking deep into the past. The sunlight touching Earth tonight left the sun about 8 minutes ago. The nearest star beyond our solar system is over 4 light-years away, meaning its light started traveling toward us before many children currently alive were even born. And distant galaxies. Their light may have started its journey billions of years ago, long before Earth even existed. Every telescope is a machine for looking backward through time. The deeper astronomers look into the cosmos, the younger the universe appears. Eventually, they reach a faint invisible boundary. A cosmic wall created not by matter, but by time itself. Beyond this boundary, light simply has not had enough time to reach Earth since the beginning of the universe. This is known as the cosmic horizon. And beyond it, the universe disappears from view. Not because nothing exists there, but because we cannot yet see it. That idea alone changes everything. Because it means the observable universe may only be a tiny bubble inside something far larger. Possibly infinitely larger. Now imagine drifting farther and farther away from Earth. Past the planets. Past the glowing clouds of the Milky Way. Beyond nearby galaxies. Beyond clusters containing trillions of stars. Eventually, the galaxies themselves begin thinning out. The darkness grows deeper. And somewhere unimaginably far away lies the edge of what humanity can observe. If you stood there somehow, staring outward into the darkness beyond the observable universe, what would you see? The strange answer is, probably more universe. More galaxies. More stars. More cosmic darkness stretching endlessly into the distance. According to many scientists, The observable universe does not have a physical edge like the wall of a room. There is no cliff where space suddenly ends. No barrier floating in darkness. The edge exists because of a limit in observation, not because the universe itself stops there. It's similar to standing in a foggy field. The fog creates a visible boundary around you. Beyond it, the world continues normally, even though you cannot see it. The observable universe may work the same way. But some theories suggest something even stranger. What if our universe is not infinite? What if space itself is curved in ways we cannot easily imagine? Some physicists compare it to the surface of Earth. If you travel across Earth long enough, you never encounter an edge. You eventually return to where you started. The universe may behave similarly in higher dimensions. Finite, but without boundaries. A shape too large for human intuition to fully understand. And then there are even more mysterious possibilities. Some theories suggest our universe could be one bubble among countless others. An endless cosmic foam where universes appear and disappear across unimaginable distances. Each one with different laws of physics. Different stars. Different histories. Perhaps even different versions of reality itself. If that is true, then what we call the universe may only be a tiny region inside something vastly greater. A multiverse. But even these ideas raise deeper questions. If universes exist beyond our own, what exists beyond them? And if space itself had a beginning, what existed before it? The closer we move toward the edge of the universe, the stranger reality becomes. Because eventually, human language itself starts breaking down. Our brains evolve to understand forests, oceans, weather, and mountains. Not infinity. Not eternal darkness. Not the possibility of countless universes floating beyond reality itself. And yet somehow, from our small planet orbiting an ordinary star, humanity has managed to glimpse the edges of existence. We have measured ancient light from nearly the beginning of time. Mapped galaxies billions of light years away. Detected invisible black holes. And discovered that the cosmos is far larger and stranger than anyone once imagined. But despite all of our discoveries, one mystery remains unsolved. What is truly outside the edge of the universe? Right now, nobody knows. Maybe there is endless space beyond our cosmic horizon. Maybe other universes drift silently beyond our own. Or maybe the idea of outside simply does not apply to the universe at all. Whatever the answer may be, one thing is certain. The deeper we explore the cosmos, the more mysterious it becomes. The universe is not standing still. At this very moment, while cities sleep and oceans quietly move beneath the moonlight, the fabric of space itself is expanding in every direction. Galaxies are drifting apart. Clusters of stars are separating across unimaginable distances. And the farther away something is, the faster it appears to move away from us. This discovery completely changed humanity's understanding of reality. For thousands of years, people assumed the universe was static and eternal. A giant unmoving stage where stars and galaxies simply existed forever. But in the early 20th century, astronomers noticed something strange. The light coming from distant galaxies looked different. When scientists split this light into colors using spectroscopy, they discovered that most galaxies appeared shifted toward the red part of the spectrum. This became known as redshift. And it revealed something incredible. The galaxies were moving away from us. At first, this sounded impossible. Was Earth somehow at the center of the universe? Were all galaxies fleeing from our location specifically? But eventually astronomers realized something much stranger was happening. The universe itself was expanding. Every region of space was stretching away from every other region. No matter where you stood in the cosmos, distant galaxies would appear to move away from you in all directions. Imagine raisins inside rising bread dough. As the dough expands, every raisin moves farther from every other raisin. None of them are at the center. The space between them is simply growing. That is our universe. And this expansion has been happening for nearly 13.8 billion years. But here's where things become truly strange. The expansion is accelerating. For a while, scientists believed gravity would slowly reduce the speed of expansion over time. After all, galaxies pull on each other through gravity. The combined mass of the universe should eventually slow everything down. But observations revealed the opposite. The expansion was speeding up. Something mysterious was overpowering gravity itself. Scientists eventually gave this unknown force a name: dark energy. Today, dark energy is believed to make up nearly 70% of the entire universe. And yet nobody truly understands what it is. We cannot see it. We cannot touch it. We cannot directly detect it. But we can observe its effects across the cosmos. It acts like an invisible pressure built into space itself, slowly pushing galaxies farther apart. And over unimaginable stretches of time, this expansion changes the entire structure of the universe. Right now, nearby galaxies are still visible to us. The Andromeda Galaxy glows faintly in the night sky, slowly moving toward the Milky Way because gravity binds our local group together. But far beyond our local region, countless galaxies are already disappearing into darkness. Not because they are dying, but because space between us is expanding too quickly. Imagine standing on a shoreline while distant boats drift farther out to sea. At first, you can still see their lights. Then they become tiny glowing dots. Eventually, they vanish beyond the horizon entirely. The universe behaves in a similar way. As galaxies move farther away, their light stretches with the expansion of space. This stretching transforms visible light into longer, weaker wavelengths. Over billions of years, the light fades until it becomes impossible to detect. One day in the extremely distant future, observers inside our galaxy may look into the night sky and see almost nothing beyond the Milky Way itself. All distant galaxies will have vanished beyond the cosmic horizon. Future civilizations might never even realize other galaxies once existed. To them, the universe could appear small, dark, and empty. And that possibility is deeply unsettling. Because right now, humanity lives during a rare era in cosmic history. An era when the universe is still visible. We can still observe ancient galaxies. Still detect relic radiation from the Big Bang. Still map enormous cosmic structures stretching across billions of light years. But this window will not remain open forever. The observable universe is constantly changing. As space expands, some regions become permanently unreachable. This creates another invisible boundary called the cosmic event horizon. Anything beyond this horizon can no longer communicate with us. No signal sent from there will ever reach Earth. Even light itself loses the race against expansion. It's difficult for the human mind to fully grasp this idea. Entire galaxies may already be forever cut off from us. Perhaps civilizations exist there. Perhaps stars are being born and dying beyond our reach. But no matter how advanced humanity becomes, we may never know. The expansion of the universe creates islands of isolation across the cosmos. And over trillions of years, those islands drift farther and farther apart. Eventually, each surviving galaxy group may become completely alone in darkness. Yet despite this loneliness, the universe itself remains astonishingly beautiful. Massive filaments of galaxies stretch across space like glowing threads in an invisible cosmic web. Between these filaments lie enormous voids almost completely empty of galaxies. Some voids are so large that light would take hundreds of millions of years to cross them. When astronomers map the universe on its largest scales, it resembles a gigantic three-dimensional network. Clusters, threads, voids. A structure so immense that it almost looks alive. And somehow, all of it emerged from tiny fluctuations in the early universe shortly after the Big Bang. Small differences in density eventually grew into galaxies, stars, planets, and people. Everything we know began from slight imperfections in the infant cosmos. Without those tiny irregularities, galaxies may never have formed at all. The universe would have remained smooth, dark, and lifeless forever. And yet, despite all our discoveries, dark energy remains one of the greatest mysteries in science. Some physicists believe it may continue accelerating expansion forever. If that happens, the future universe becomes cold and empty. Galaxies disappear. Stars eventually burn out. Black holes slowly evaporate over unimaginable spans of time. The cosmos fades into darkness. But other theories suggest something even stranger could happen. What if dark energy becomes stronger over time? What if the expansion eventually grows so powerful that galaxies themselves are torn apart? Then stars. Then planets. Then atoms. This terrifying possibility is known as the Big Rip. In that scenario, the expansion of space eventually overcomes every force in existence. Gravity fails. Matter itself dissolves. And the universe ends in total destruction. But for now, the cosmos continues expanding silently around us. Every second, distant galaxies move farther away into darkness. Every second, the observable universe changes shape. And somewhere beyond our cosmic horizon, regions of space continue expanding forever beyond human sight. Perhaps endlessly. Perhaps toward other universes. Or perhaps toward realities we cannot yet imagine. The deeper scientists study expansion, the clearer one thing becomes. The universe is far larger and far stranger than humanity once believed. Imagine floating completely alone in space. No spacecraft, no sound, no up or down. Only darkness stretching endlessly in every direction. Ahead of you lies the farthest boundary humanity can observe, the cosmic horizon. Beyond it, the universe disappears. Not because space ends there, but because light from farther regions has never had enough time to reach us. This invisible boundary surrounds Earth like a giant cosmic shell. And everything humanity has ever seen exists inside it. Every galaxy, black hole, and star in the night sky. Just a tiny visible region inside something potentially far larger. But what lies beyond that horizon? That question has fascinated scientists for decades. And strangely enough, the answer may depend on the shape of the universe itself. Most people naturally imagine space as infinite and flat. A giant endless emptiness stretching forever in all directions. And according to current observations, the universe does appear remarkably flat on large scales. But there's a difference between appearing flat and truly being infinite. Think about Earth. When you stand on the ground, the planet feels flat beneath your feet. Oceans seem level. Fields stretch outward like endless plains. Yet Earth is curved. It's only because the planet is so enormous compared to us that the curvature becomes difficult to notice. Some scientists believe the universe may work the same way. Space itself could be curved in higher dimensions beyond ordinary human intuition. If that's true, then the universe may not be infinite after all. Instead, it could wrap around itself in ways almost impossible to visualize. In such a universe, if you traveled in one direction long enough, you might eventually return to your starting point. Not because you turned around, but because space itself loops back onto itself. A finite universe without edges. That idea sounds strange at first. How can something be finite without having a boundary? The answer lies in geometry beyond everyday experience. Imagine an ant crawling across the surface of a sphere. From the ant's perspective, the world has no visible edge. It can walk forever without falling off. Yet the surface area of the sphere is still finite. Similarly, our universe may have no edge in the traditional sense while still containing a limited amount of space. But if space curves back on itself, what exactly exists outside it? This is where human intuition begins to fail. Because the universe does not expand into empty space the way an explosion expands into air. Space itself is the thing expanding. As strange as it sounds, asking what is outside the universe may be similar to asking what is north of the North Pole. The question itself may not fully apply. Still, many physicists believe there could be something beyond our universe. And some of the most fascinating theories suggest our cosmos might only be one region inside something vastly larger. A multiverse. Imagine reality as a gigantic cosmic ocean filled with bubbles. Each bubble is its own universe. Inside each one, stars form, galaxies evolve, and time flows according to different physical laws. Some universes may resemble ours. Others could be completely alien. In some, gravity might work differently. In others, stars may never form at all. Some universes could exist for only moments before collapsing back into nothingness. Others may expand forever. According to certain inflation theories, new universes may constantly appear as space itself continues expanding eternally. Our universe would simply be one bubble among countless others. A tiny island in an endless cosmic sea. And perhaps beyond our observable horizon, new universes are being born even now. Completely disconnected from us forever. This idea sounds like science fiction. But surprisingly, some versions of the multiverse theory emerge naturally from mathematics used in modern cosmology. And while there is still no direct proof, the possibility cannot be fully dismissed. The deeper scientists study the cosmos, the more reality begins to resemble something stranger than fiction itself. But there are even more mysterious possibilities. Some theories suggest our universe could exist inside a higher dimensional structure. A kind of cosmic membrane floating through dimensions humans cannot directly perceive. In these models, what we experience as reality may only be a small slice of something far greater. Additional dimensions could exist all around us right now, hidden beyond our senses. And perhaps entire universes drift through those dimensions unseen. It's difficult to truly imagine. Human brains evolved to survive on the surface of a small planet. We understand distance, gravity, and motion through ordinary experience. But the universe operates on scales far beyond ordinary thought. Billions of galaxies. Trillions of stars. Distances so large that light itself requires millions or billions of years to cross them. And beyond all of that, perhaps even more realities. Yet despite these extraordinary ideas, scientists remain cautious. Because there is a problem. We may never directly observe anything beyond the cosmic horizon. No matter how advanced our technology becomes, some regions of reality could remain permanently inaccessible. The expansion of the universe itself prevents information from reaching us. That means certain mysteries may never be solved completely. Humanity may forever remain trapped inside a visible bubble surrounded by unreachable darkness. But even if we cannot directly see beyond the observable universe, the cosmos still leaves behind clues. Ancient radiation from the Big Bang. Patterns in galaxy distribution. Subtle fluctuations in space itself. Scientists study these clues like detectives examining footprints left behind at a cosmic crime scene. And sometimes, those clues hint that reality may be even larger than we imagined. Because when astronomers map the universe on enormous scales, they find structures so gigantic they challenge comprehension. Galactic filaments stretching across hundreds of millions of light years. Clusters containing thousands of galaxies. And between them, vast cosmic voids. Immense empty regions where almost nothing exists. Some voids are so enormous that light takes hundreds of millions of years to cross them. And these strange dark regions raise another unsettling possibility. What if emptiness itself contains hidden secrets? What if the largest structures in existence are not galaxies, but the spaces between them? As humanity continues exploring the edge of the observable universe, one thing becomes increasingly clear. The cosmos is not simple. It is layered with mysteries. Invisible boundaries. Hidden dimensions. Unreachable regions. Possibly even other universes beyond our own. And every answer seems to lead toward even deeper questions. Because perhaps the greatest discovery humanity has ever made is this: the universe is under no obligation to make sense to us. When most people imagine space, they picture stars. Bright galaxies glowing across the darkness. Nebulas filled with color. Planets orbiting distant suns. But the truth is, most of the universe is almost completely empty. Between the great clusters of galaxies lie enormous regions of darkness known as cosmic voids. These voids are among the largest structures in existence. And strangely enough, they may hold some of the deepest secrets about the universe itself. At first, astronomers didn't even realize voids existed. For centuries, humanity could only observe a small portion of the cosmos. Early telescopes revealed stars and nearby galaxies, but the larger structure of the universe remained hidden. Then, during the 20th century, astronomy changed forever. Powerful telescopes and advanced surveys allowed scientists to map the positions of galaxies across immense distances. And what they discovered was unexpected. Galaxies were not spread evenly throughout the universe. Instead, they formed gigantic interconnected structures. Long filaments of galaxies stretched across space like glowing cosmic threads. Clusters gathered together like cities in the darkness. And between them existed vast empty regions where almost nothing could be found. It was as if the universe itself had formed a giant web. And the spaces between its strands became known as voids. Some of these voids are difficult to comprehend. Imagine a region so enormous that light would require hundreds of millions of years to cross from one side to the other. A place containing almost no galaxies at all. Just darkness. Cold. Silent. Endless. One of the most famous examples is the Boötes Void. Discovered in 1981, this gigantic region spans roughly 330 million light-years across. To understand how enormous that truly is, remember that our entire Milky Way galaxy is around 100,000 light-years wide. The Boötes Void is thousands of times larger. Inside a region where astronomers expected to find thousands of galaxies, they found almost nothing. Only a few scattered galaxies drifting through immense emptiness. It became known as the Great Nothing. And the deeper scientists studied it, the stranger it seemed. Because according to our understanding of cosmology, matter should have spread more evenly after the Big Bang. So how could regions this empty exist at all? The answer may lie in the earliest moments of the universe. Shortly after the Big Bang, tiny fluctuations appeared in the density of matter and energy. Some regions became slightly denser than others. Over billions of years, gravity amplified these differences. Dense regions attracted more matter, eventually forming galaxies and clusters. Meanwhile, less dense regions lost material over time. As matter flowed outward toward denser areas, vast empty spaces slowly emerged. The universe separated itself into structure and emptiness. Into filaments and voids. In a strange way, galaxies may only exist because emptiness exists too. Without voids pulling matter outward into enormous structures, the cosmic web may never have formed at all. But some voids are so enormous that scientists still struggle to explain them completely. And certain voids appear connected to even deeper cosmic mysteries. One of the strangest examples involves something called the cold spot. When astronomers mapped the cosmic microwave background, the ancient radiation left over from the Big Bang, they discovered a huge unusually cold region in the sky. This cold spot appeared slightly different from surrounding regions of space. At first, scientists thought it might simply be random. But later observations revealed something remarkable. A gigantic supervoid appeared to exist in that exact direction. Some researchers believe light traveling through this enormous empty region lost energy during its journey toward Earth, creating the strange cold signature astronomers observed. If true, this means cosmic voids can actually influence the oldest visible light in the universe. The emptiness itself leaves fingerprints across reality. And that idea is deeply unsettling. Because we usually think of emptiness as nothing. But in cosmology, emptiness has structure, shape, influence, power. In fact, voids may tell scientists as much about the universe as galaxies do. By studying how voids expand and evolve, researchers gain clues about dark matter and dark energy, the invisible forces shaping the cosmos. Dark matter acts like an unseen skeleton supporting the cosmic web. Its gravity helps pull galaxies together into enormous filaments and clusters. Meanwhile, dark energy pushes the universe outward, accelerating expansion across space itself. Voids become laboratories where these mysterious forces reveal their effects most clearly. Inside these enormous empty regions, galaxies drift farther apart as expansion continues. Over trillions of years, the voids themselves may grow even larger. The universe could eventually become dominated by darkness and emptiness. Clusters of galaxies isolated like lonely islands inside an endless cosmic ocean. And yet, despite their emptiness, voids are strangely beautiful. Imagine floating through one. No nearby stars. No glowing galaxies lighting the darkness. Only distant points of light scattered across unimaginable emptiness. The silence would feel absolute. A darkness so deep that the Milky Way itself might appear like a tiny glowing cloud far away in the distance. Human beings evolved surrounded by light, sound, weather, movement, and life. A true cosmic void would feel almost unnatural. A place where reality itself seems unfinished. And yet these empty regions make up much of the observable universe. The cosmos is not mostly filled with stars. It is mostly emptiness. This realization changes how we see existence itself. Everything humanity has ever known exists on tiny islands of matter floating inside enormous oceans of nothingness. Just tiny structures surrounded by vast darkness. And perhaps beyond the observable universe, even larger voids exist. Regions so immense that our minds cannot properly visualize them. Some scientists have even wondered whether certain voids could hint at interactions with other universes beyond our own. Others speculate that unknown physics may shape these giant empty regions in ways we do not yet understand. Right now, nobody knows for certain. But every time astronomers map another region of the cosmos, one thing becomes increasingly clear. The universe is not random chaos. It has structure, patterns, invisible architecture stretching across billions of light years. And somehow, emptiness itself became one of the most important parts of that design. Because without the darkness between galaxies, the universe we know may never have formed at all. About 13.8 billion years ago, the universe began. At least, that's what modern cosmology tells us. Before that moment, there were no stars, no planets, no galaxies, no atoms, not even space itself. Everything we know today was compressed into an unimaginably hot and dense state. Then suddenly, the universe expanded. Space itself began unfolding in every direction. This event became known as the Big Bang. And for a long time, many people imagined it as a giant explosion happening somewhere in empty space. But the truth is stranger than that. The Big Bang was not an explosion inside the universe. It was the beginning of the universe itself. Space expanded everywhere at once. There was no center, no edge, no outside location where someone could stand and watch it happen. The universe did not expand into empty space. Space itself was being created. And that leads to one of the most difficult questions in all of science. What existed before the Big Bang? At first, the answer seems obvious. Surely something had to come before it. After all, in everyday life, everything has a cause. Rain comes from clouds. Trees grow from seeds. Stars form from collapsing gas. So naturally, the human mind wants to ask what created the universe itself. But this is where reality becomes deeply strange. According to Einstein's theory of relativity, time and space are connected. They form a single structure called spacetime. And if spacetime itself began with the Big Bang, then time may not have existed before that moment. In other words, there may not have been a before. That idea is extremely difficult for the human brain to accept. Our entire experience is built around time. Past, present, future, cause and effect. But near the beginning of the universe, those ordinary ideas may completely break down. Some physicists compare it to standing at the North Pole and asking what lies farther north. The question itself stops making sense. If time began with the Big Bang, then asking what happened before it may be impossible in the normal sense. Still, scientists have proposed many fascinating theories trying to understand what might have existed before our universe formed. One of the oldest ideas is called the oscillating universe theory. According to this model, the universe may go through endless cycles: expansion, contraction, rebirth. The cosmos grows outward for billions or trillions of years. Then gravity eventually slows the expansion and reverses it. Galaxies begin falling back together. Temperatures rise. The universe collapses inward toward a state known as the Big Crunch. At the final moment, all matter and energy become compressed into an incredibly dense point. Then another Big Bang occurs. A new universe is born. In this theory, our universe is only one phase in an endless cosmic cycle without true beginning or end. A universe breathing in and out forever. Creation followed by destruction. Then creation once again. It's a beautiful idea. Almost poetic. But current evidence suggests the expansion of the universe is accelerating rather than slowing down, making this scenario less likely according to modern observations. Still, the concept remains one of the most fascinating possibilities in cosmology. Another theory suggests something even stranger. What if our universe is only one among countless others? This is the idea behind the multiverse. Imagine reality as an endless cosmic ocean filled with bubbles. Each bubble contains its own universe. Inside every universe, different physical laws may exist. Some universes may have stronger gravity. Others may never form stars. Some might collapse instantly. Others may expand forever. According to certain versions of inflation theory, new universes could constantly appear as space expands eternally. Our universe would simply be one bubble among infinitely many. And perhaps the Big Bang was not truly the beginning of everything. Only the birth of our local region of reality. But if countless universes exist, another question appears. What created the multiverse itself? And once again, the mystery continues deeper. Then there's another possibility. One connected to quantum mechanics. In the quantum world, empty space is not truly empty. Tiny particles constantly appear and disappear in what scientists call vacuum fluctuations. Space behaves almost like a bubbling ocean of energy. Some physicists suggest our universe may have emerged from one of these fluctuations. A tiny quantum event expanding rapidly into everything we know today. In this model, the universe itself could have begun spontaneously from quantum processes. A random fluctuation becoming reality. But perhaps the strangest theory of all involves black holes. Black holes are regions where gravity becomes so powerful that nothing, not even light, can escape. At their centers lies a singularity, a point where density becomes effectively infinite. The laws of physics break down there completely. Some researchers believe our universe itself may have formed inside a black hole existing within another universe. According to this idea, every black hole could potentially create a new expanding universe inside it. Our cosmos would then be the interior of a black hole born from some larger parent universe beyond our own. And inside our universe, black holes may themselves create entirely new realities. A never-ending chain of universes giving birth to other universes. It sounds impossible. Yet mathematically, some versions of the idea remain surprisingly difficult to rule out. Then there's string theory. One of the most ambitious attempts to unite quantum mechanics and gravity. In string theory, the fundamental building blocks of reality are not particles, but tiny vibrating strings. Different vibrations create different particles. Like notes played on a cosmic instrument. String theory also suggests additional dimensions beyond the 3 dimensions humans experience. These hidden dimensions may exist everywhere around us, curled up beyond direct observation. Some versions of string theory propose that our universe formed after enormous higher dimensional structures collided. The Big Bang would then represent the aftermath of a cosmic collision between gigantic multidimensional membranes called brains. And somewhere beyond our observable universe, other brains, and other universes, may drift silently through higher dimensions. The deeper scientists investigate the beginning of reality, the stranger everything becomes. Every answer creates new questions. What caused the laws of physics themselves? Why does anything exist at all instead of nothing? Why does the universe allow stars, planets, life, and consciousness to emerge? Right now, nobody knows. And perhaps some mysteries will remain forever beyond human understanding. But there's something strangely beautiful about that. Humanity exists on a small rocky planet orbiting an ordinary star near the edge of an ordinary galaxy. And somehow, from this tiny corner of the cosmos, we learn to ask questions about the beginning of existence itself. Questions so large that even the universe struggles to answer them. And perhaps that endless search for understanding is one of the most remarkable things the cosmos has ever created. When we look up at the night sky, it feels calm. Still. Almost simple. Stars scattered across darkness like distant candles. But on the largest scales, the universe is anything but simple. It is structured. Organized in a way that looks almost intentional, even though it is shaped entirely by gravity and time. Astronomers call this structure the cosmic web. A vast interconnected network of galaxies stretching across the observable universe. And once you understand it, you start to see something strange. The universe is not filled evenly with matter. It is arranged like a giant invisible pattern. Long filaments of galaxies stretch across space like threads. At the intersections of these filaments are galaxy clusters. Massive collections containing thousands of galaxies bound together by gravity. And between these structures lie enormous empty regions. Cosmic voids. Together, these elements form something like a 3-dimensional web suspended in space. But unlike any web we know, this one is built from galaxies themselves. Each galaxy is like a glowing node of light, slowly drifting along invisible gravitational paths carved out billions of years ago. And all of this structure began from something incredibly small. In the early universe, shortly after the Big Bang, space was almost completely uniform. But not perfectly uniform. Tiny fluctuations existed in the density of matter. Some regions were slightly denser than others. And over time, gravity began to amplify those tiny differences. Denser regions pulled in more matter. Less dense regions lost material. Slowly, structure emerged. It took billions of years for the universe to transform from a nearly smooth state into the complex cosmic web we see today. And yet even now, this structure is still evolving. Galaxies continue moving. Clusters continue forming. Voids continue expanding. The universe is not frozen in time. It is still under construction. But there is something even more mysterious hidden inside this structure. Because when astronomers map the distribution of galaxies across enormous distances, they discover something unexpected. The cosmic web is not random. It contains patterns that repeat across different scales. Like echoes of the same underlying process shaping reality again and again. Some regions are densely packed with galaxies. Others are almost completely empty. And between them, filaments stretch like bridges connecting everything together. It almost feels like the universe is balancing itself between structure and emptiness, between presence and absence, between light and darkness. And in that balance, cosmic voids play a crucial role. At first, voids were thought to be simple empty gaps, regions where nothing happened. But modern astronomy shows they are far more important than that. Voids are dynamic. They expand over time. As matter flows outward into denser regions, voids grow larger and emptier. In a sense, they are not just empty spaces. They are expanding regions of absence. And that raises a fascinating idea. Maybe emptiness is not nothing. Maybe emptiness is something with behavior, structure, and influence. Some scientists even suggest that voids help shape the motion of galaxies around them, like invisible forces sculpting the flow of matter across the universe. But there is still another layer to this structure. Something even deeper. Because when we zoom out far enough, beyond individual filaments and clusters, something surprising appears. The cosmic web itself is not evenly distributed. It has shape on scales so large that they challenge our understanding of how the universe formed. Some regions contain enormous superclusters of galaxies. Others contain vast supervoids stretching hundreds of millions of light years. And sometimes, these voids appear larger than standard models of cosmology would predict. Which raises a difficult question. Did structure form exactly as we expect? Or is something missing in our understanding of how the universe evolved? To explore this, scientists use simulations. They recreate the universe inside powerful computers, starting from the conditions of the early cosmos. Tiny fluctuations are added. Gravity is allowed to act over billions of years. And slowly, virtual universes grow. And remarkably, these simulations often match what we observe in reality. But sometimes, they don't match perfectly. Certain large structures in the real universe appear more extreme than expected. Some voids seem too large. Some filaments too long. Some clusters too massive. And these small differences may hold clues about unknown physics. Dark matter. Dark energy. Or something even deeper that we have not yet discovered. Dark matter, for example, is invisible. It does not emit light. It does not absorb light. It does not interact with light at all. And yet its gravity shapes the entire cosmic web. Without dark matter, galaxies might not have formed the way they did. The universe would look completely different. More scattered. Less structured. Almost unrecognizable. Meanwhile, dark energy pushes the universe apart, slowly stretching space itself, competing with gravity in a quiet cosmic struggle that continues even now. Together, these invisible components determine the fate of everything we see. And yet we still do not know what they are. Only that they exist through their effects. Which leads to a strange realization. Most of the universe is invisible. Not just distant galaxies beyond our horizon, but the very forces shaping everything we can observe. And so the cosmic web becomes more than just a structure of galaxies. It becomes a map of hidden physics. A frozen record of forces we cannot directly see. Every filament, every void, every cluster, all shaped by invisible components woven into the fabric of space itself. And when we step back and look at it from the largest scale, something almost poetic appears. The universe is not chaotic. It is structured like a living pattern. Not designed in a human sense, but shaped by laws that produce order from randomness over billions of years. And still, despite all this structure, the largest question remains unanswered. What lies beyond it? Beyond the cosmic web? Beyond the observable universe? Beyond the reach of light itself? Because no matter how far we map the cosmos, there is always a boundary we cannot cross. A limit defined not by space itself, but by time, and by the speed of light. And just beyond that limit lies the unknown. Every time we look deeper into space, we are also looking backward in time. That is one of the most important truths in astronomy. Light is not instant. It travels slowly, but incredibly fast by human standards. And because of that, everything we see in the night sky is already history. The sun we see is 8 minutes old. Proxima Centauri is over 4 years old in our view. And distant galaxies are seen as they were millions or even billions of years ago. So when we observe the universe, we are never seeing it now. We are always seeing a memory of it. And this leads to something called the observable universe. The observable universe is the region of space from which light has had enough time to reach us since the beginning of everything. It forms a kind of cosmic horizon. A boundary defined not by physical walls, but by time and expansion. At present, this observable radius stretches about 46.5 billion light-years in every direction. Which sounds impossible at first, because the universe itself is only 13.8 billion years old. So how can we see farther than 13.8 billion light-years? The answer lies in expansion. Space itself has been stretching while light was traveling through it. So the places that emitted that ancient light are now much farther away than they were when the light first began its journey. While light moved through it, the universe expanded underneath it. And that creates a strange situation. We are not inside a fixed-sized object. We are inside an expanding system where distances constantly change. Which means the edge of what we can see is not a wall. It is a limit of information. A boundary of visibility. And beyond that boundary there may be much more universe that we will never see. Not because it does not exist, but because its light has not had enough time, or may never have enough time, to reach us. This is where the idea of cosmic horizons becomes important. There are actually different kinds of horizons in cosmology. One of them is the particle horizon. This is the limit of what we can see from the past. It represents the farthest distance from which light has reached us since the beginning of the universe. But there is also another limit. A more unsettling one. The event horizon of the universe. This is not about the past. It is about the future. It marks the boundary beyond which light emitted today will never reach us, no matter how long we wait. Because the universe is expanding faster and faster due to dark energy, some regions of space are being carried away so quickly that their light can never bridge the distance. Even if they shine forever. Even if they burn brightly for trillions of years. Their light will still never arrive. It is a silent separation. No explosion. No destruction. Just increasing distance over time. And that leads to a strange conclusion. There are galaxies in the universe right now that we can see today, but will never be able to reach. And there are galaxies that exist right now that we will never even know about. Because their light will never arrive. It is as if the universe is slowly drawing invisible lines between everything. Separating regions of reality that were once connected. And as time passes, more of the universe slips beyond that horizon. Forever. But this is not the only boundary. There is also something called the Hubble horizon. This is related to the expansion speed of space itself. At extremely large distances, galaxies appear to recede from us faster than the speed of light. Not because they are moving through space faster than light, but because space itself is expanding between us and them. This creates a strange illusion. Some objects are carried away so fast that their light cannot reach us even if it is already traveling toward us. They are effectively pushed beyond the limit of contact. And yet, the Hubble horizon is not fixed. It changes over time. It expands. Meaning that some light that is currently unreachable may eventually become visible in the far future. But not all of it. Some regions will remain forever disconnected. So when we look at the universe, we are not seeing everything that exists. we are seeing only what is allowed to reach us. A filtered version of reality shaped by expansion, time, and the speed of light. And this raises a deeply uncomfortable idea. The universe may be far larger than what we can ever observe. Possibly infinitely larger. With regions forever outside our reach. Outside our knowledge. Outside our science. And yet still real. Still existing. Still part of the same cosmic whole. But forever silent to us. As if the universe is speaking in different directions at once, but we can only hear a small part of it. And everything else remains muted behind distance and expansion. Even more strangely, this boundary is not static. It evolves. In the early universe, everything was much closer together. Light could travel freely across enormous regions. But as expansion continued, new regions slowly crossed beyond our visible limit. And this process continues even now. Every second, the observable universe becomes slightly larger in one sense, and slightly more isolated in another. We gain new visible light from ancient sources. But we also lose potential contact with distant future light. It is a cosmic trade. Visibility for separation. Knowledge for isolation. And this leads to a profound realization. The universe is not just something we observe. It is something we are trapped inside observationally. We can explore it. We can map it. We can study it. But we cannot step outside its limits to see the full structure from the outside. There is no external viewpoint. No cosmic balcony. No higher position where the entire universe can be seen at once. We are always inside the system we are trying to understand. And that makes the edge of the universe not just a physical concept, but a philosophical one. Because the edge is not a place. It is a limit of perception. A boundary defined by what information can reach us, and what cannot. So when we ask, what is outside the edge of the universe? The answer may be both simple and unsettling. It might not be an edge at all. Only more universe. Expanding forever. Beyond what we can ever see. Beyond what we can ever know. And yet still connected to everything we are part of. Even if we will never touch it. If the universe is expanding, then nothing inside it stays truly still. Everything is moving. Not just through space, but with space itself. And over time, that movement adds up in a way that completely reshapes reality. Galaxies drift apart. Clusters slowly lose connection. Entire regions of the cosmos become increasingly isolated. And what once felt like a single connected universe begins to look more like separated islands of matter in an endless dark ocean. But the most important part is this. It is not that things are moving away through space. It is that space itself is stretching. And that distinction changes everything. Because in a normal expanding explosion, you could imagine debris flying outward into empty space. But in the universe, there is no outside space to expand into. Space is the thing expanding. Which means every region of the universe is carried along with the expansion itself. And from our perspective, distant galaxies appear to move away faster the farther they are. At small distances, gravity holds things together. Galaxies remain intact. Star systems stay stable. Even clusters of galaxies can resist expansion. But at larger and larger scales, expansion wins. And the universe begins to break apart into separate regions that no longer influence each other. This is where the idea of the cosmic event horizon becomes truly important. Because there is a point beyond which the expansion of space effectively cuts communication forever. Even light cannot overcome it. Not because it loses speed, but because space expands faster than light can travel across it. So imagine a galaxy far away from us. Right now, its light is still reaching us. We can observe it, study it, map it. But as time passes, that same galaxy slowly drifts beyond the point where its future light can ever reach us. One day, it will no longer be observable. And after that, it will slowly fade from our cosmic view. Not because it disappears, but because its light is stretched, weakened, and eventually lost to expansion. From that moment onward, it becomes permanently unreachable. And this process is happening right now. Across the universe. Silently. Constantly. Which means the observable universe is not just a fixed snapshot. It is an evolving region. A window that changes over time. Some parts of the universe are being added to our view, while others are being removed forever. And that creates a strange imbalance. We are gaining information from the distant past, while simultaneously losing access to parts of the distant future. And if we imagine far enough ahead in time, something even more dramatic happens. The universe begins to isolate itself. Today, we live in a universe where galaxies are still relatively connected on large scales. But in the far future, the situation becomes very different. The expansion driven by dark energy continues accelerating. And eventually, only gravitationally bound systems remain connected. For example, galaxies within a local cluster will remain together. But everything beyond that cluster will drift away beyond the horizon. So if we imagine the far future, the night sky would not look like it does today. Instead of thousands of visible galaxies, there would be only a single island of light. Our local galaxy group. Everything else would be gone from view. Not destroyed. Just unreachable. As if the rest of the universe had vanished into darkness. But it is still there. Just no longer visible. And this leads to a profound thought. Future civilizations, if they exist far enough ahead, might look at the sky and believe the universe is small. They would see only their local cluster of galaxies. No distant structures. No cosmic web. No hint of a larger universe beyond their reach. They would not know that billions of galaxies once filled the sky. Because the expansion of space would have erased all evidence from their observable horizon. In that sense, the universe slowly hides itself from its own observers. It does not end. It simply becomes less accessible, less connected, more isolated. But this isolation is not only spatial. It is also temporal. Because light itself has a finite speed, we are always seeing the universe as it was in the past. And as time passes, we are constantly updating our view of cosmic history. We are not just observing space. We are reading time written in light. And every photon that reaches us carries information from a specific moment in the universe's past. This means astronomy is not just spatial exploration. It is time travel through observation. We are seeing ancient galaxies as they were billions of years ago. We are seeing the early structure of the universe forming in real time from our perspective. But this also means there is a limit. A boundary where even ancient light cannot reach us. And beyond that boundary, the universe becomes completely invisible. Not because it stops existing, but because its information can no longer travel to us. This is where the idea of the edge becomes misleading. Because the edge is not a physical boundary. It is a communication limit. A point where causality itself breaks between regions of space. And in that sense, the universe is divided not by walls, but by accessibility. Some regions can influence us. Some can be observed. And others are forever beyond interaction. Which means the universe is not fully connected in a global sense. It is a patchwork of regions tied together by the speed of light and the expansion of space. And as time continues, those patches shrink relative to each other. Connections weaken. Visibility fades. And isolation increases. But even in this quiet separation, something remarkable remains. We are still able to see deep into the past of the universe. We are still able to reconstruct its history. we are still able to understand that everything began from a hot, dense, rapidly expanding state. And from that beginning, structure formed. And eventually, observers like us appeared, able to ask questions about the universe itself. Which brings everything back to a simple but powerful realization. The universe is not only something we live inside. It is something we are reading. Across billions of years of light arriving from distant time. And even as parts of it slip beyond our reach, the story we can still see is already vast beyond imagination. A story written in expanding space. And carried to us across the deepest darkness. There is a strange idea in cosmology that becomes more unsettling the longer you think about it. The universe does not need observers. It existed for billions of years before anything could look at it. And it may continue long after there is nothing left capable of watching it happen. Stars will form. Stars will die. Galaxies will merge and drift apart. Black holes will grow, evaporate, and disappear. And through all of it, the universe continues its evolution completely indifferent to whether anyone is there to witness it. From its point of view, nothing is missing. No audience is required. No meaning is needed. Only physical law. But from our point of view, everything changes because we are here to observe it. We are temporary witnesses to a process that is far larger than awareness itself. And that creates a deep tension between reality as it is and reality as it is experienced. Because what we see is always limited. Not only by distance, but by time, light, and the structure of the cosmos itself. We live inside a universe that is constantly revealing only fragments of itself. And those fragments are slowly being taken away as expansion continues. If we imagine far into the future, that process becomes extreme. Eventually, all galaxies outside our local gravitational group disappear from view. The cosmic web fades. Distant structures vanish. The night sky becomes simpler. And finally, only a single bound system remains visible. A local island of stars surrounded by darkness. No trace of the wider universe would remain observable. And if that future observer tried to reconstruct cosmology, they might reach a completely different conclusion. They might not discover an expanding universe filled with galaxies. They might instead believe they live inside a static, isolated system. Because all evidence of the larger cosmos would have been stretched beyond their horizon. This idea leads to something deeply important. Our understanding of the universe is time-dependent. We are living in a very special moment. A moment where the universe is still visible. Still structured. Still revealing its large-scale complexity. But this window is not permanent. It is slowly closing. Gradually over unimaginable timescales. Like a fading signal stretching into silence. And yet, even in this fading universe, something continues. Entropy. The slow increase of disorder. The spreading out of energy. The inevitable tendency for differences in temperature and structure to disappear. Hot things cool down. Cold regions warm slightly. Energy spreads more evenly. And over vast timescales, the universe moves toward a state where nothing significant can happen anymore. This is sometimes called the heat-death scenario. Not a death in the dramatic sense, but a final state of balance, where energy is so evenly distributed that no processes can occur that create change or structure. No stars forming. No galaxies merging. No meaningful gradients of energy left to drive motion. Only a uniform, cold, expanding emptiness. But even before that final stage, the universe becomes increasingly quiet. Stars burn out. New stars form less frequently. Black holes dominate the centers of galaxies. And over trillions of years, even those black holes slowly evaporate through quantum effects. One by one, the most massive objects in the universe disappear. Until only diffuse radiation and elementary particles remain. And even those eventually spread so thinly that interactions become almost impossible. At that point, the universe is still there. But it has lost almost everything that gives it structure or activity. No structure large enough to be called a galaxy. No long-lived stars. No obvious centers of gravity shaping motion on large scales. Just an expanding background of fading energy. And yet, even in this extreme future, the laws of physics still operate. Gravity still exists. Quantum mechanics still applies. Space still expands. But there is nothing left to organize. Nothing left to transform. Nothing left to observe change. Which leads to a strange reflection. The universe may not end. But it may stop being interesting in any physical sense. Not because it disappears, but because it becomes featureless. And that raises another question. If a universe evolves into a state where nothing can be observed or measured in a meaningful way, does it still matter in the same sense? Physics would say yes. Reality does not depend on observers. But experience suggests otherwise. Because experience requires change. And change requires differences. And differences require structure. Without structure, there is no story left to tell. But before reaching that distant future, there is still another fascinating layer to consider. The role of observation itself. We often think of observation as passive. Simply looking at what already exists. But in physics, especially quantum physics, observation plays a deeper role. On very small scales, the act of measurement is part of the system. Reality does not behave like a fixed, pre-written script. Instead, it behaves more like a set of probabilities that become definite only when interactions occur. This does not mean consciousness creates reality. But it does mean that interaction is fundamental. And every time light reaches a telescope, or a detector records a signal, the universe is actively revealing one of its possible histories. So in a very real sense, the universe is constantly interacting with itself through observation. We are not outside observers. We are part of the network through which the universe becomes knowable. But as expansion continues and horizons grow, fewer interactions become possible. Less of the universe can ever influence us. And less of what exists can ever be known. Which means that over time, the universe becomes not only more distant, but more silent. And that silence is not empty in a simple sense. It is structured by horizons. Boundaries of causality. Limits of communication. Edges defined by the speed of light and the expansion of space. So when we ask what lies beyond the observable universe, we are not just asking about distance. We are asking about communication itself. About whether parts of reality exist that are forever cut off from interaction. And according to our current understanding, the answer may be yes. There may be regions of space that will never, under any circumstance, influence us again. Not now. Not in the far future. Not even in principle. And those regions are still part of reality. They are not outside the universe. They are just outside our connection to it. Which brings everything back to a quiet conclusion. The universe is not a single fully accessible object. It is a growing, expanding structure of regions gradually losing contact with each other. And we are living inside one of those regions. For now, still connected enough to see far. Still early enough in cosmic history to witness structure. Still positioned at a moment where the universe can be understood. But that moment is not guaranteed to last forever. And in that sense, we are not just observers of the universe. We are witnesses in transit. Passing through a brief window where the cosmos is still open enough to be seen. If the universe has an edge we can never cross, then the final question is not only what lies beyond it, but what happens when even the idea of an edge stops meaning anything at all. Because every horizon we've talked about, particle horizon, event horizon, Hubble horizon, all of them depend on one thing. Light reaching us. signals making the journey across space and time. But horizons are not physical walls. They are limits of contact. And limits can change. They grow. They shrink. They evolve with the expansion of the universe. Which means that edge is not a fixed boundary. It is something dynamic. Something alive in a mathematical sense. And over time, that edge slowly reshapes what reality means for any observer inside it. In the distant future, as expansion continues, the observable universe will shrink in a very strange way from the inside. Not because space disappears, but because fewer and fewer regions remain connected by light. Galaxies outside a gravitationally bound system will slip away so far that their light becomes forever unreachable. And the sky will become simpler, then emptier, then almost static. But even that is not the final transformation. Because over even longer timescales, something deeper happens. Stars die. Black holes evaporate. And the universe transitions into a state where almost all usable energy gradients are gone. At that point, there is still space. But almost no structure capable of producing change. No engines. No stars. No chemistry complex enough to build new patterns easily. Just an expanding, fading background. And in that final quiet, the universe no longer looks like a story. It looks like a condition. A state rather than an unfolding process. But here is where things become truly strange. Because even in that extremely distant future, the geometry of spacetime still exists. Expansion still happens. Quantum fluctuations still occur at some level. And black holes, if any remain, still slowly evaporate over unimaginable timescales. So the universe is never truly stopped. It is always evolving. But the scale of meaningful change becomes so large, and the energy difference is so small, that from any practical perspective, nothing seems to happen anymore. It is not an end in the dramatic sense. It is an end in the sense of possibility. And that leads to one of the deepest ideas in cosmology. The universe may not end in time, but it may end in structure. Meaning that what disappears is not existence itself, but the ability for complexity to form. For observers to arise. For information to be processed in meaningful ways. And if that is true, then the universe's most important phase might not be its beginning or its end. But this middle period we are living in right now. A rare interval where energy differences are large enough to create stars. Where gravity is strong enough to form galaxies. Where chemistry is rich enough to support life. And where observers can exist long enough to ask questions about all of it. We are not at the beginning. We are not at the end. We are inside the era where the universe is still structured enough to be understood. And that is what makes this moment so unusual. Because if the universe evolves through stages, from simple to structured to dispersed, then consciousness exists only in the structured phase. Not in the beginning of pure plasma. Not in the end of heat-death. But in the narrow band where complexity is possible. Which means every observation we make is happening during a temporary window in cosmic history. A window that will not last forever. And that brings us back to the question we started with. What is outside the edge of the universe? But now, after everything we've explored, the question shifts slightly. Because maybe there is no single edge. Maybe there are layers of edges. Edges of visibility. Edges of causality. Edges of interaction. Edges of meaning. Each one expanding or dissolving depending on the scale of time you look at. And beyond all of them, there may not be outside in the way we imagine. Because outside implies a boundary you can cross. A place you can step into. But the universe may not have that kind of structure at all. It may simply extend beyond what can ever be observed. Not as a wall. Not as a limit. But as continuation without access. And if that is true, then the most profound truth is this. We are not separated from the universe by distance. We are separated by the speed of light, by expansion, and by time itself. And those limits do not divide reality into inside and outside. They divide it into what can be known and what cannot. So when we look into the night sky, we are not just seeing distant stars. We are seeing the portion of reality that has managed to stay connected to us across billions of years. A visible island of the cosmos, floating in a much larger, mostly unseen ocean. And that ocean may be infinite, or finite, or something else entirely that our current physics cannot yet describe. But in every case, one thing remains consistent. The universe is always larger than what we can observe. And our understanding of it is always partial. Which is not a failure of science. It is its defining condition. Because science does not require total access to reality. It only requires enough connection to uncover patterns within it. And from those patterns, we have already learned something extraordinary. That the universe has a history. That it evolves. That it expands. That it forms structure from simplicity. And that it contains observers capable of recognizing all of this. Which brings everything to a quiet final reflection. The universe does not need to be fully seen to be real. And we do not need to see everything to understand something profound about it. We exist in a small, temporary window of cosmic visibility, looking outward into distances that may never be fully reachable, listening to light that has traveled for billions of years just to arrive here, and trying, from inside a moving, expanding system, to understand the whole of what surrounds us. And maybe that is the most important part. Not that we see everything, but that we can see anything at all.